In this particular section, we're applying our knowledge of meiosis and Mendel's laws of inheritance to pedigree analysis. And so in the reading study guide, I ask you to look at the 6 different modes of inheritance. Those are autosomal dominant and recessive, X-linked dominant and recessive, Y-linked, and mitochondrial. Now, some guidelines to help you get started when you're faced with a pedigree that you are asking a question, is this pedigree compatible with one of the 6 particular modes of inheritance? Because in the book itself, in the Genetics for Dummies book, it shows you, it makes a statement about a mode of inheritance, and then it shows you a pedigree that's compatible with it. And that's certainly an important way to learn this. But the ultimate goal that you're moving towards is you would be able to take a pedigree and be able to ask the question, is this pedigree compatible with autosomal dominant, autosomal recessive, X-linked dominant or X-linked recessive, Y-linked or mitochondrial? Now, there are a series of statements in the book for each of the different modes of inheritance that show characteristics. It is absolutely essential that you go through those lists one by one and use Punnett squares to help make sure you can understand why those statements are the way they are. So for example, when they talk about a characteristic of autosomal traits, they say equal numbers of males and females are affected. Why would that make sense? Because autosomal traits are not involving the sex chromosomes. So we would expect to see equal numbers of males and equal numbers of females for each of those particular modes of inheritance. Now, what I've put together are 2 slides that show additional guidelines when you're starting with a pedigree, and again, you're asking that question, is it compatible with a particular mode of inheritance? So, the first statement, if you're assuming autosomal dominant inheritance, in other words, you're saying, I'm going to see if this pedigree is compatible with autosomal dominant inheritance, the question becomes, where do you start? And here's the answer. Start with unaffected individuals. Right, the individuals whose symbols are not colored in. Because if you're assuming autosomal dominant inheritance, then you know the unaffected individuals have to be homozygous recessive. Then any individual that's affected has to be either homozygous dominant or heterozygous. Now, the way you'll try to figure that out is either by looking at the affected individual's parents or by looking at the offspring. Because if that affected individual is a partner in the production of a child that is unaffected, then that tells me immediately that that affected individual has to be heterozygous, because he would have to be, or she would have to be able to pass a recessive allele on to result in the production of an unaffected child. So if you're assuming autosomal dominant, this is the place to start. Secondly, if you're assuming autosomal recessive inheritance, then you want to start with all the affected individuals. Why? Because if we're assuming autosomal recessive, we know the affected individuals must be homozygous recessive. And the unaffected individuals must be either homozygous dominant or heterozygous. Now, using the same line of thinking with the previous statement, if we have 2 unaffected individuals that produce an affected child, and we're assuming autosomal recessive, then both of those parents would have to be heterozygous, because that's the only way you could produce a child that would be homozygous recessive. So when you're starting to analyze a pedigree and you're trying out autosomal dominant and autosomal recessive, these are statements that you want to keep in mind as to where do I start with the analysis of this pedigree.